same. Okay, now, in order to give you a clue about what I did to A and B, I'm going to do something with C. This is can C. It's a different color, but it's the same kind of can. Okay, now I want you to watch what I do and everything I do with can C, because that'll give you some clues about what I did with A or B. Okay, I have this cup of water, and I'm going to pour it in here. Now I'm going to put it on the hot plate and heat it up. And I want you to let me know when you see a lot of steam coming out of there. When we see a lot of steam, I'll do the next step. Okay, now let's go back to A and B. We're going to do this focus a little bit different today. I'm not going to have you ask data questions. I'm going to have you suggest steps that I took in the experiment. Okay, I started with two identical cans, A and B. Now, remember I said what I do with C will give you some clues about what I did with A or B. So, started with two identical empty cans, A and B. Can anybody suggest what I did next? Somebody ought to be able to figure out what I did next. Emily?
Put some water in them.
Well, I put water in B, but I didn't put water in A. Okay? You should already know what the manipulated variable is. Raise your hand if you can tell me the manipulated variable in one word. Mason. Water is the manipulated variable. So that means everything else has to be controlled. Why do you only want one manipulated variable in the experiment? Who can tell me that? Emily B?
Because if you have two, then you don't know which one is causing it.
Right, you don't know which one causes the results. Okay, so water is the manipulated variable. We have enough data already to write a tentative conclusion because B contained water, but A didn't. Okay, we can call that valid and reliable. Does anybody know the two conditions that determine whether a conclusion is valid and reliable? What's one thing that has to be true? The data have to do what? Have to what? No, well, they have to not refute it.
Yeah.
They have to not prove it false. What do they have to do? They have to not refute it. What do they have to do, Tanner?
How to set it up.
Well, that's not exactly it. What do the data have to do, Emily?
Support.
They have to support it. Well, these diagrams amount to data today. And this one has water and this one doesn't. So, that conclusion is supported by the data and not refuted by the data. But it's not a complete conclusion because you need to know more than that in order to explain exactly why B collapsed. Does anybody want to try to explain why B collapsed at this point? Why do you think B collapsed, Jeremy?
Because since you said that you put the water in it, maybe like the water it evaporated and sucked all the air out with it or something.
Okay, that's his hypothesis. An unsupported statement is called a hypothesis. If it's supported, then you call it a conclusion. You want? Oh, there's steam?
It's not that steam, but the.
Now there's a little steam. Raise your hand if you can see the steam.
It's just a little bit.
I just see it.
You see the steam, Justin or Darby? See the steam?
I don't.
Well, more and more is coming out all the time.
I see it.
Okay, there's steam coming out.
I don't see it.
Now, I'm going to put this cap on. you hear something significant, raise your hand. I haven't heard anything significant yet. Hear that? How many heard that? How many heard that? Okay. How many see something happening? What's the can doing? One word. What's the can doing in one word? Denting. What's a better word? Jackie?
Collapsing.
Collapsing. Raise your hand if you can see that the can is collapsing. All right, if I let that cool long enough, it would look like this. But I don't want to let it cool that long because I have to use this can over and over, and these cans cost about $5 a piece. If I let that happen a couple of times like that, it'd get a hole in it. So here's what I'm going to do. I'll take these down so you can see what's happening here. I'm going to put it back on the hot plate now. And I'm going to put my goggles on. Why am I putting my goggles on? Who wants to suggest why? Raise your hand if you want to suggest why I'm putting my goggles on. Janelle? What might happen to the can if I'm not careful? It might explode. And then I would lose my eyesight. And so, well, no, I wouldn't lose my eyesight because I've got goggles on, but Jacob and Stevie might lose their eyesight if I'm not careful. Okay, now, how long am I going to let this sit?
Not much longer.
How long? Until what happens? Boom! I think I better take it off now or it might explode.
Yeah.
I've done this hundreds of times and it's never exploded.
I never know. I
You never know, so I put my goggles on every time. All right, now I'll put this over here, out of the way. Okay, now we'll go back to A and B. A is not collapsed, but B is. All right, now. We know that I put water in B, but not A. Then what did I do? What's the next step I did, Megan? Megan?
You put A on there without any water on it, and it didn't dent.
Okay, what she's saying is I heated them next. I heated them. Okay? How long did I heat them? I heated them until what happened? Phoebe? Until steam came out of B. Did I heat them the same amount of time?
Yeah.
Why do you know I heated them the same amount of time? Why do you know that? Wyatt?
Because it's then
Well,
Anybody besides Wyatt know why I heated? You know, you have to know that I heated them the same amount of time. Why, Darby?
If you didn't heat them for the same amount of time, then you would have two
You have two
manipulated.
manipulated variables. Okay, so I heated them. Now, before I started to heat them, this one was filled with air. Those are air molecules. Okay? And this space here in B was filled with air. You know that because they don't have any caps yet, all right? Now, so I heated them. How long did I heat them? Raise your hand if you can tell me how long I heated them, Jonathan.
Until the steam was coming out.
Until steam came out of B. Okay, then, who knows what I did next? Who wants to suggest what I did next? What did I do next, Jackie?
you put the cap on?
I put the caps on. Okay. Oh, I forgot one thing. Gosh, I forgot a very important thing here before I put the caps on.
Oh.
This air was heated. Who knows what happens to air when you heat it? Anybody know in one word what happens to air when you heat it? Chase? What's the word? Who knows the one word that describes what happens to air when you heat it? Jeremy?
Does it rise?
No. Well, yes, it rises because it does something else. Nobody knows what air does when you heat it? Megan? No? What? Well, you're close. It expands. So this air in here expanded slightly. Like that. This air expanded slightly too. Okay? But what happens to water when you heat it? What happens to water when you heat it, Jake?
It turns into steam.
Turns into steam. So part of this water turned into steam. Okay? Well, actually, the steam filled up the can. The steam that formed from the water filled up the can. Like this. Those are steam molecules. Gaseous water. What happened to the air that was in there? Who knows what happened to the air that was in there, Tanner? It came out. It was forced out. All that air was forced out. Okay. Now, then what did I do, Jackie?
Put the caps on.
I put the caps on. Tightly. Okay, then what did I do, Megan?
Then you took them off.
Took them off the heat and let them cool. Okay, and I watched them. And after about 5 minutes, A looked like this, and B looked like this. Listen, what do you hear?
Water.
Listen, what do you hear?
Nothing.
Air.
He fixed me.
Now, here's something that most of you probably don't know. All around us, the air pressure is 14 pounds per square inch. PPSI, pounds per square inch. That's at sea level, and we're near sea level here. All around the world, all around the earth, the air pressure at sea level is about 14 pounds. Now there's a square inch. That's about a square inch. For every square inch of your skin, there's 14 pounds of air pressing on it. So that's a lot of pressure. That's about the weight of that projector over there. If you held that out in your hand, you couldn't hold your arm out very long because it would get tired. Well, if there's 14 pounds of pressure pressing on every square inch of your skin, why don't you feel it? Who wants to suggest why you don't feel it, Allie? You're used to it. You were born in it, you lived in it all your life. However, if the pressure goes significantly below 15 or significantly above 15, you don't feel it. You feel best in 14. Okay? Now, what happens if air expands when you heat it? What happens to air when you cool it? Does anybody know what happens to air when you cool it? What? What's the opposite of expand? Anybody know a word that means the opposite of expand? What? Well, that's close. That's close. Emily?
Shrinks?
Shrink is close. Begins with a C. What does air do when you cool it? The opposite of expand, begin with a C. Got this many letters? C, O, N, T, R, A, C. Contracts. Well, that air, the lid's on. So when that air contracts, the pressure goes down to about 13 inside there. All right? What happens to steam when you cool it? Who knows that? Who knows what happens to steam when you cool it? Tanner?
Does it get heavier?
No. Jake?
It turns to fog.
Not to fog, no. What does it turn into? Jonathan?
Clouds.
No.
Water.
Water. Turns back into liquid water. So when this one cooled, all of the steam that was in here turned back into liquid water. Leaving behind what?
Nothing.
Nothing. What's a space with nothing in it called? Anybody know? Okay, it has this many letters. Say it when you know it. This is a space with nothing in it. V, A, C, U, U, M. Who said vacuum first? Was that Tanner? Vacuum is something, a space with nothing in it. Outer space, when you get beyond our atmosphere into outer space, it's a vacuum, nothing is in it. Okay, well, who can guess what, if there's nothing in here, who can guess what the air pressure must be? Who wants to guess what the air pressure must be? Jonathan?
0.
Zero. Zero. All right. So in can A, you end up with 14 pressing against 13. Well, there's hardly any difference. 14 pressing against 13 doesn't make much difference. But in B, you end up with 14 pressing against 0. Makes a lot of difference. There's 14 pounds per square inch, but if you calculate the number of square inches in the surface of this can, you come up with about 500 pounds of pressure pressing on that can. If you put a 500-pound weight on that can, it would collapse like that too. Okay. So, what's the key word for this focus?
Vacuum?
No.
Vacuum.
What's the key word that causes it to collapse? What? Key word that causes it to collapse? Emily?
Water.
No. Tanner? Megan? Janelle?
Air.
Jonathan?
Steam.
Emily? Pressure causes it to collapse.
Air.
All right, it's the difference in pressure between the inside and the outside. The purpose of this demonstration, which has been demonstrated at colleges and high schools for years, is to demonstrate the power of air pressure. But a lot of people don't know about that. Okay. Now we're ready to complete our conclusion. This is still reliable and valid because B contained water, but A didn't. But now we have to add some more. When both were heated